Welcome to this edition of the Designs for Health audio science article.
Hippocrates may not have been right that all disease starts in the gut, but certainly the integrity of the gut lining and proper intestinal function are key players in the immune system's frontline defenses against illness. With regard to physical integrity and proper functioning of the gut, we typically think of leaky gut and the role of tight junctions, the connections between cells lining the intestines, but no less important is the mucosal barrier formed by the gut epithelial cells and the substances they secrete. Recent technological advances hold promise for bringing relief to those who live with autoimmune or inflammatory intestinal conditions. Therapies for gut-related issues may be about to go very high-tech. One of these interesting developments has been called a probiotic band-aid for the gut. Developed at Harvard University's Weiss Institute for Biologically Inspired Engineering, this compound is a probiotic hydrogel that can be applied to the inner surface of the gut like a living bandage to physically seal mucosal barrier breaches and promote healing without involving the immune system. As explained by the creator of the hydrogel, it contains a specific strain of E. coli bacteria engineered to secrete a biofilm that physically binds to the gut mucosal layer. The gel can be introduced via oral ingestion, injection, or endoscope, and it is self-regenerating because the bacteria within it constantly synthesize the adhesive compounds that bind it to the surface of the gut. When administered orally in mice, the hydrogel survived the acidic environment of the stomach and remained in the small intestine for at least 5 days. Shorter-lived treatments can be created by killing the bacteria before the introduction of the hydrogel into the gut. According to an article about the research provided by Harvard, in the intestine, the engineered bacteria produce a network of nanofibers that directly binds to mucus to fill inflamed areas like a patch, shielding them from gut microbes and environmental factors. This probiotic-based therapeutic strategy protected mice against the effects of colitis induced by a chemical agent and promoted mucosal healing. The probiotic band-aid description is rooted in one of the apparent advantages the hydrogel has over other therapies, such as anti-inflammatory drugs and antibiotics used to treat localized infections. Even though the gel is administered orally, once it reaches the intestine, it applies itself directly to inflamed lesions from inside the gut lumen. Think of it like applying a soothing layer of aloe vera to a sunburn. Human research has yet to be conducted using this brand new technology, but if these impressive effects can eventually be replicated in humans, this novel therapy has the potential to be helpful for individuals who respond poorly to anti-inflammatory drugs and other treatments typically used to fight certain intestinal pathologies. Details on the research and development of the hydrogel can be found in the original paper in Nature Communications. Since it might be a very long time before these intriguing technologies are available for routine use in humans, in the meantime, certain compounds may be beneficial for helping to restore and maintain a healthy gut mucosal layer. Among these are zinc carnosine, okra, marshmallow root extract, slippery elm, and licorice. Another interesting technology on the horizon has potential through a separate mechanism to aid in the healing of the gut mucosa and restoring healthy barrier function. Also developed by researchers at the Weiss Institute, the technology involves new aryl hydrocarbon receptor agonists, or AHR agonists. As described in a paper about this research, the AHR is an essential regulator of the gut innate immune system and mediates processes including expression of interleukin-22, which are responsible for gut barrier function and microbial homeostasis. Deactivation of the AHR has been shown to cause intestinal barrier dysfunction, while activating it stimulates immune cells that secrete compounds that promote repair. Targeting the AHR pathway represents a promising therapeutic target for restoration and maintenance of intestinal integrity. But efforts aimed at this have failed due to inadequate pharmacokinetics, direct toxicity, and promising results in mouse models that did not translate into humans. The research done so far with these new AHR agonists has been in mouse and human gut cells in vitro and in mice in vivo. When administered orally to mice with colitis, the compounds led to significant improvement in the animal's health and survival. As with the hydrogel, more research is needed before this can be tested in humans, but it's encouraging to know novel strategies for these sometimes debilitating intestinal conditions are on the radar.
Thanks for listening. For more excellent educational content, be sure to visit designsforhealth.com.